What if I told you that NASA's most advanced telescope, the James Webb, just spotted something in the darkest corner of space that shouldn't exist? A massive, glowing object so ancient, so powerful, that it defies every law of physics we know. Astronomers are baffled. Theories are collapsing. And the deeper Webb looks, the more terrifying it becomes. Because this isn't just a star, or a black hole. It might be something else entirely. Stay tuned, because what the James Webb Telescope just discovered could change everything we thought we knew about the universe. The James Webb Space Telescope, humanity's most powerful eye into the cosmos, has just sent back images that left even the world's top scientists speechless. What they found out there isn't just puzzling, it's downright terrifying. An object so massive, so ancient, and so luminous that it seems to break every known rule of space and time. Since its launch, the James Webb Telescope has delivered breathtaking discoveries. Galaxies born just a few 100 million years after the Big Bang, stars in their infancy, and mysterious exoplanets that might harbor life. But this time, what it captured is nothing like anything seen before. At first glance, scientists thought it was a simple light anomaly, maybe a glitch in the telescope's sensors or a distant galaxy caught mid-collapse. But when they zoomed in and studied the data, everything changed. The light patterns didn't match any known star, galaxy, or black hole. Its energy signature pulsed irregularly, almost as if it was alive. And here's where things get even stranger. The object appeared to be older than the universe itself. Let that sink in. Something existed before everything we know began. NASA officials have been cautious, releasing only fragments of the data, while independent researchers are calling it one of the most disturbing findings in modern astrophysics. In this video, we're going to break down what the James Webb Telescope really saw, why scientists are so unsettled by it, and what it could mean for humanity's understanding of the universe. From new theories of time loops to whispers of unknown cosmic entities, this story is going to challenge everything you thought you knew about space. But before we dive in, remember, what you're about to see isn't science fiction. It's real, documented, and verified data straight from NASA's own observatories. And by the end of this video, you'll understand why so many experts are saying that this discovery could change the course of astrophysics forever. Now let's start with what exactly the James Webb Telescope saw, and why this discovery has the entire scientific community on edge. When the James Webb Space Telescope locked its golden mirrors onto a region of deep space near the constellation Cetus, scientists expected to find nothing unusual, perhaps a few faint galaxies or a new cluster of stars. But as the data streamed in, researchers at NASA's Goddard Space Flight Center began noticing something that didn't add up. Amidst the cold emptiness of intergalactic space, Webb's sensors picked up a point of light so bright that it shouldn't have been visible from that distance. The object seemed to emit a constant stream of infrared radiation, but here's the twist: it didn't behave like any known galaxy, quasar, or nebula. Its energy signature was completely unique. Normally, when Webb observes distant galaxies, the light it captures is stretched, what astronomers call redshift, due to the universe's expansion. The farther away the object, the more redshifted its light becomes. But this one was different. Its light spectrum showed irregular patterns. Certain wavelengths didn't match any cosmic model scientists have ever used. It was as if the object's light was bending in ways no one could explain. At first, NASA's internal teams thought it was a data artifact, perhaps a calibration error. So they ran multiple scans over the same region, checking the readings again and again. Each time, the same mysterious glow appeared. The same pulsing infrared waves. The same gravitational distortion. When they finally mapped the surrounding area, something even more astonishing came to light. Every nearby galaxy seemed slightly warped, as if this unknown object was bending space itself. That level of gravitational distortion is usually only seen around supermassive black holes, but this object wasn't behaving like a black hole at all. It was emitting light, not swallowing it. As days turned into weeks, the team cross-verified the data with multiple instruments. The European Space Agency and the Canadian Space Agency, both partners in the James Webb Project, independently confirmed the readings. There was no mistake. Something enormous and ancient was sitting out there, emitting energy older than any galaxy Webb had ever seen. The data suggested the object existed approximately 13.8 billion light-years away, which would place it at the very edge of the observable universe. But here's where things defy logic. Based on the object's light and energy patterns, it should predate the Big Bang. Scientists ran the numbers over and over again, but the math didn't make sense. How can something exist before time and space even began? To make matters more unsettling, the object didn't remain static. Over the course of several weeks, Webb's infrared readings showed subtle but noticeable changes. Fluctuations in brightness that seemed almost rhythmic, like a heartbeat. Some scientists dismissed it as cosmic dust interference. Others weren't so sure. In one of the raw images leaked from an internal NASA data stream, researchers noticed faint rings surrounding the central light source, concentric circles that looked eerily similar to gravitational waves. But those waves were far too strong to come from a typical star or planet. In fact, the last time astronomers recorded something of that magnitude was during the detection of colliding black holes. But again, this object was neither collapsing nor exploding. It was just pulsing. Rumors began to spread within the astrophysics community. Was this the signature of a new kind of celestial body? A remnant from a universe before ours? Or something even stranger, an artificial construct built by an unknown intelligence? NASA refused to comment on that speculation, but the timing of the agency's silence only fueled more curiosity. Then came the most chilling detail of all. When the telescope's infrared sensors focused on the object's outer edges, the data showed a faint pattern that looked eerily geometric, almost as if the light was being emitted in structured intervals. That's not something nature usually does by accident. By now, scientists from multiple observatories around the world were analyzing the same coordinates. The object was officially catalogued as JWS 231b, but within the research community, it quickly earned a far more ominous nickname: the Pulse. And here's where the story takes a darker turn. Because what Webb saw next, in its follow-up scans, left even the most skeptical astronomers genuinely disturbed. Stay with me, because in the next section, we'll uncover what the follow-up data revealed about the Pulse, and why some researchers are calling it the most frightening discovery in modern astronomy. After weeks of quiet observation, the mysterious object, now known as the Pulse, began to behave in ways that defied all known astrophysical laws. The James Webb Space Telescope's advanced infrared instruments continued tracking it from millions of miles away, transmitting streams of raw data back to Earth. But what the scientists saw next left them both fascinated and terrified. Every few hours, the pulse emitted a sudden flash of energy so powerful that it briefly interfered with other deep space readings. These bursts weren't random. They followed a pattern, a rhythm so precise, so consistent, that it resembled a repeating signal. The energy waves would build, peak, and then fade, only to return again, almost exactly 6 hours later. At first, NASA thought the readings were coming from a pulsar, a rapidly spinning neutron star known for emitting beams of radiation. But the energy signature didn't match. Pulsars have predictable electromagnetic frequencies. The pulse, on the other hand, emitted light waves that fluctuated unpredictably between the infrared and microwave bands. It was as if it were deliberately altering its signal, changing frequencies in a sequence no one could decode. Scientists ran simulations to test every possible natural explanation. Could it be an unstable quasar? A collapsed star? A dying galaxy throwing off its final bursts of energy? None of those theories held up. The pulse was located in a region of deep space where no galaxies should even exist, a cosmic void, utterly empty. And yet, this one object was shining brighter than an entire cluster of stars combined. As more data poured in, researchers started noticing an even stranger anomaly. The light being emitted from the pulse didn't just illuminate the surrounding space, it appeared to bend it. Webb's cameras picked up distortions around the object that couldn't be explained by normal gravitational lensing. The area around the pulse seemed to shimmer and ripple, as if reality itself was being stretched and folded. When the telescope zoomed in further, the core of the object displayed a spiral-like formation, not unlike a galaxy, but rotating in the opposite direction of everything else in the known universe. This counter-rotation defied the basic laws of angular momentum. It was as though the object existed in a completely different timeline, one where physics operated under a separate set of rules. At this point, things took a turn behind the scenes. Internal NASA communications were quietly encrypted, and the public access data feed from the Webb telescope temporarily went offline for what officials described as routine maintenance. For 3 days, no new data was released. When the feed returned, many astronomers noticed that several recent observation files were missing. That silence only deepened the mystery. Independent researchers from Europe and Asia, who had been monitoring the same coordinates using ground-based observatories, reported similar findings, pulses of light visible in the same sequence, at the same intervals. Whatever the pulse was, it wasn't confined to Webb's instruments. It was real. A leaked report from one of the partner agencies described the object's light emissions as having non-random periodicity, meaning the pulses were structured in a way that suggested intent. That one word, intent, sent shockwaves through the global scientific community. Were they implying that the pulse could be artificial? Publicly, NASA denied any claims of an extraterrestrial origin. But privately, scientists were asking hard questions. Could this be a beacon? A remnant of an ancient civilization lost to time? Or was it something more fundamental, a natural cosmic phenomenon from a universe that existed before our own? As data analysis continued, astrophysicists noticed another terrifying detail. Each pulse emitted by the object seemed to slightly alter the energy field around it. Over time, these distortions appear to spread outward, subtly influencing nearby space. Some predicted that if the pattern continued, the gravitational effects might one day ripple across millions of light years. That meant whatever the pulse was doing, it wasn't isolated, it was expanding. One research paper, quickly withdrawn from an academic archive after only 12 hours, claimed that the pattern of the pulse corresponded to the Fibonacci sequence, a mathematical ratio found in both nature and complex design. Was that a coincidence? Or was the universe trying to tell us something through numbers? A senior astrophysicist from Cambridge, speaking under anonymity, reportedly said, "If this signal is what it appears to be, it means we're not observing the universe. The universe might be observing us." While official agencies downplayed such remarks, the implications were staggering. If the pulse wasn't just emitting energy but transmitting information, it could be a message traveling through time, not just across space. The question is, a message from whom, or from what? Once the existence of the pulse was confirmed, the world's brightest scientific minds began racing to explain what it could be. At first, the theories were grounded in traditional astrophysics. But as more data poured in, and as the object continued to defy every known model of cosmic behavior, those theories began to crumble, forcing experts to consider ideas once dismissed as pure science fiction. The first and most widely discussed theory came from a group of astrophysicists at Caltech. They proposed that the pulse could be what's called a pregalactic remnant, a fragment of energy left over from before the Big Bang. According to this model, the universe didn't begin from a single explosion, but from a series of cyclical expansions and contractions, what some call the Big Bounce theory. If that's true, the pulse might be a leftover structure from a universe that existed before ours. But there's a major problem with that idea. If the pulse predates the Big Bang, that means it survived the collapse of an entire universe, an event so violent it should have obliterated everything down to subatomic dust. The fact that it's still there, still emitting measurable energy, suggests it's not just a remnant. It's active. And that means it might have some form of self-sustaining power, something beyond our current understanding of physics. Another theory emerged from the European Space Agency, where a small team suggested the pulse might be the core of a dark star. Unlike normal stars powered by nuclear fusion, dark stars are theorized to run on dark matter, the mysterious, invisible substance that makes up most of the universe. These stars, if they exist, could generate energy through the annihilation of dark matter particles. If the pulse were such a star, it would explain its brightness and unusual radiation patterns. But again, there's a catch. Dark matter is supposed to be undetectable by electromagnetic sensors. It doesn't emit light, it doesn't absorb it, and it doesn't reflect it. So how could Webb possibly be seeing it? The only explanation is that something within the pulse is interacting with normal matter in a way never observed before, as if it's blending the visible and invisible sides of the cosmos into one. Then came the most controversial theory yet, and the one NASA has refused to officially acknowledge. Some scientists believe the pulse could be an artificial object. Not a star. Not a galaxy. But a megastructure, possibly built by an advanced civilization billions of years older than humanity. This idea gained traction after a leaked internal document surfaced online, allegedly from within NASA's Jet Propulsion Laboratory. It described a strange periodic pattern in the pulse's emissions that resembled binary code, zeros and ones. The signal wasn't continuous, but in bursts, short and long, repeating in intervals that mirrored patterns found in digital communication. While the authenticity of the document has never been confirmed, it reignited public debate. Was the pulse a natural phenomenon, or a cosmic transmitter sending a message across time and space? A renowned astrophysicist, Dr. Eliza Moreno, put it bluntly during a private symposium. If the pulse is artificial, it means two things. 1, we are not alone in the universe. And 2, whoever or whatever created it understood the laws of physics far beyond our comprehension. But even if the object were artificial, who built it, and why? Some researchers speculated it could be the remnant of an extinct civilization that mastered interdimensional technology, leaving behind a beacon that survived cosmic resets. Others suggested it might not be built by beings like us at all, but by the universe itself, a kind of self-aware mechanism designed to monitor the birth and death of reality. The idea sounds wild, but here's where it gets even more disturbing. When the James Webb team analyzed the time intervals between each pulse, they found that the object's energy emissions were slightly decreasing over time, as if it were running out of fuel. That detail led to an entirely new hypothesis. The pulse might be dying. And if it's dying, that means it was alive, in some way we don't yet understand. The notion of a living cosmic structure isn't as far-fetched as it sounds. Some physicists have long speculated that certain regions of spacetime could behave like conscious systems, capable of adapting and reacting. If that's true, the pulse could be the heartbeat of a universal entity, something ancient, aware, and slowly fading away. But what happens if it stops pulsing? Some fear that its disappearance could have profound consequences. The rhythmic pattern of its emissions appears to synchronize faintly with cosmic background radiation, the afterglow of the Big Bang. If the two are somehow connected, the death of the pulse might disrupt that balance, possibly altering the expansion rate of the universe itself. Then, there's the most chilling theory of all. A small but vocal group of physicists and mathematicians believe the pulse isn't sending out a message at all. Instead, it's listening. The object's rhythmic waves might not be transmissions, but reflections, a form of cosmic sonar scanning the fabric of reality for intelligent life. If that's true, then when we detected it, it detected us. NASA has neither confirmed nor denied these possibilities. Officially, they refer to the pulse as a deep field anomaly of undetermined origin. But privately, insiders have hinted that new data from Webb's mid-infrared instrument could be even more alarming. One researcher, speaking off record, claimed that the object's latest pulse included a brief but measurable echo, as though something, somewhere out there, responded. Whether that's a data glitch, or the first evidence of two-way communication remains unknown. But one thing is clear, the pulse isn't going away. It's still out there, glowing faintly at the edge of existence, continuing its steady rhythm as the universe expands around it.